Welcome to The Explainer. So you've probably used RxJS. You've heard all about streams and events. But today, we're going to unlock a much more powerful way to think about it as a complete signal processing system, one that's built specifically for software.
Okay, let's just dive right into the heart of the confusion that trips up so many developers. We're always talking about signals and streams. They're related, for sure, but they are very, very different concepts. And really, getting them straight is the first big step.
And here it is, the core of the puzzle. Is a signal an event stream, or is it just state? I mean, on one hand, we're told it represents a value over time. But then every time it changes, it seems to fire off an event. So which one is it? Let's get to the bottom of this.
You know, the distinction gets a whole lot clearer when you just put them side by side. A signal has all the characteristics of state. It's about the current value, a single value you can read anytime. It's just there. An event stream, though, that's about a whole sequence of things happening over time. And this right here, this is where the lines get blurry for so many of us. The signal itself is definitely state, but every single time that state changes, it produces an event. You know, a dependent function reruns or an effect fires off a network request. Those moments, they feel like a stream, and that's where the confusion comes from. So here's the crucial point. While a signal's update is an event, the signal itself is absolutely not an event stream. It just doesn't have any of the core characteristics. It doesn't have a complete state, it doesn't have an error channel, and it's not about a series of separate occurrences. It represents a single continuous piece of state. To really make this idea stick, we're going to borrow a mental model from a field that's been wrestling with these ideas for decades, classical engineering. And you're about to see this isn't just some loose comparison. The parallels are pretty much exact. So in engineering, a signal has a really formal definition. It's just a function of time that carries information. Think of a sound wave hitting a microphone or a voltage reading from a sensor. It's a value that changes, and that change carries meaning. And this isn't some obscure academic idea. This model is the foundation of almost all of our modern tech. It's how your phone talks to a cell tower, how self-driving cars figure out what's around them, and even how we analyze brain activity. This is a battle-tested, absolutely fundamental model of the world. The classical model is actually really simple. It breaks down into just three parts. You have a sensor, which is just something that produces data. You have the signal itself, which is the structured information from that sensor. And finally, you have a handler, a passive component that just receives and reacts to the signal. That's it. Sensor, signal, handler. Okay, and this is where it gets really powerful. That classical engineering model, it maps almost perfectly onto the world of RxJS. I'm not talking kind of similar. The parallels are nearly identical. Let's just walk through it. So let's start with the source. In RxJS, an observable acts exactly like a sensor. It produces values over time, right? Whether that's from a user clicking a button, a WebSocket pushing down a message, or just a simple timer. It is our software sensor. Now this is a really key insight. An observable doesn't just spit out raw values. It emits these structured things called notifications. Next, error, or complete. These notifications are the actual signals. They give us a rich, structured representation of whatever our sensor, the observable, just detected. And finally, that brings us to the observer. The observer is our handler. It's just that set of callbacks, our next, error, and complete functions that passively listens for the notifications and decides what to do about them. It's the receiver for our signals. And when you lay it all out like this, the mapping is it's a near-perfect one-to-one fit. The classical idea of a filter, that's an RxJS operator. Random noise in a system, well, that's what the error channel is. Even a state variable from control theory maps directly to a modern UI signal. So when you see a mapping this powerful, this one-to-one, it really forces you to reevaluate what RxJS actually is. It's not just some library for managing events, it's something way more fundamental. And this is the big idea. This is probably the most precise way to describe the library's architecture. RxJS isn't like a signal processing system. For all intents and purposes, it is one. Just one that's built for software. You could get really formal and use the long version on the left, but honestly, the phrase software events is just so powerful because it already implies the other stuff. I mean, software events are, by definition, discrete in time and happen at the software level. So the shorter version is not just more elegant, it's more precise. So here it is, the complete system, all laid out. Observables are our sensors. Operators are our filters. The schedulers, they act as our sampling clocks, deciding when things get processed. And effects are the actuators. They're the parts of the system that actually go and change the world by updating the UI or making an API call.
Okay, I get it. This is a neat analogy, but what's the practical benefit? Why does this actually matter? Let's talk about how this perspective makes reactive programming feel so much more intuitive. Well, first, it gives you this incredibly clean conceptual ladder. You can now see the clear path all the way from a raw, messy event like a mouse click to a structured notification, which then gets wrapped in an observable and is finally distilled down into a clean, reactive piece of state, a signal. It's a clear lineage. And look, understanding this isn't just some academic exercise. It actually helps you predict how RxJS is going to behave. When you start thinking in terms of sensors, filters, and actuators, you're tapping into decades of established engineering principles that are robust, predictable, and incredibly powerful. And that's the ultimate takeaway here. We haven't just learned a new analogy. We've replaced a bunch of confusing, disconnected ideas with a single, coherent mental model. And suddenly, it all just clicks into place. Observables as sensors, operators as filters, and signals as state. It all just makes sense, clarifying the role of every single piece of the RxJS ecosystem. This whole explainer really highlights the power of looking outside our own field for better models. And it leaves us with one final thought to ponder. What other rock-solid ideas from engineering or science are just sitting out there, waiting to simplify the way we all write code? Thanks for joining us on The Explainer.